All right. Hello, everybody. My name is Arun. I work out of the Uber office in New York City. I'm an engineering manager on the Uber Eats team. And I figured I'll spend the rest of about 20 minutes or so walking through some of the things we do here in the office in New York, talk a little bit about the Uber Eats product and some of the interesting engineering challenges we're solving. I figured these sort of presentations, it's more useful to go super deep on one specific team and some of the challenges there to give you a flavor of the type of work rather than a super broad overview, which you can easily get by going online or using the product yourself. So let me kind of dive in and I'll go through some slides. So I've been at Uber now for about 3.5 years. My background is before Uber, I was at a tiny little startup. Before that, I was at Google. Before that, I was sort of a medium-sized company for almost a decade. So I've been at bigger companies and smaller companies, and it's been a lot of fun going, kind of been in the journey at Uber, a fast-growing company with its own ups and downs, and learning a lot and building some cool stuff. Talk a little bit about the New York City office where I'm based out of. I figured wanted to make this as sort of my sort of perspective and personal as possible rather than give a company-wide perspective. The engineering office in New York started in 2015, early, about summer of 2015. I joined in summer, so pretty small team at that point. Now we're over 250 people in technology here and trying to grow really fast in 2019. Beyond that, we have about two large engineering teams. One is focused on Uber Eats, which is a very product-oriented engineering team. Another one focused on infrastructure and observability, which is all about how do you manage and observe and alert and fix microservices that we use a lot of. The observability team has actually open sourced a lot of things interesting that's interesting. M3, Jaeger, you can look this up on our GitHub site. Pretty cool stuff that they've built. They build tools for other engineers, while Uber Eats team builds tools and products for external facing constituents. Pretty good mix of experience level here in the office, anywhere from just out of school and interns to people that have been in the industry for 20 years or so. Always good to kind of have that mix of experience level to get good dialogue going, good mentorship and support, and challenging perspectives, and everything is really powerful to have. One of the nice things about the way we build offices is we have a lot of local leadership and have all sorts of different functions sit together. So it's not like where your design team or your product management team is in a different office or your manager is in a different office. So it's kind of an awkward relationship. It's all kind of local, so you feel part of a same community. And then we're always looking to hire. Excited about some of all the great things we've heard from Lambda folks. So hoping to find some great talent here. Hope you'll be excited about us as well. And then across different stacks and different technologies, always looking to hire across all these different things. Some of the photos of our office. We just moved into a new office with a lot of sunlight, so that's great. So specifically, let me talk a little bit about Uber Eats. Hopefully you all have tried it. The product is about 3 years old. We launched in December 2015 in Toronto, our first city. And then starting about February 2016, we've been scaling across hundreds of different cities, and it's kind of done quite well. It's a complex product, so hopefully it'll be an interesting one for you all to hear about. The journey is back in 2014, we started a pilot called Uber Fresh, which is just in Los Angeles. It's all about groceries and other things delivered from the Uber app. Then we started Uber Eats Instant, which is prepared meals, but a very limited selection that's available within the press of a button in the Rides app. Then in 2016, we launched the app, and then 2017 and beyond, it's sort of the right food for the right now. So you can see actually some of the interesting examples of how we did it. In the past, we had Eats as an option in the Rides app, so you kind of just slide the slider and get it. Awkward metaphor, but it helped us test and experiment and scale pretty quickly. And then on the right, you have an earlier version of what the app looked like, where you could see hundreds of selection that you can get from. Uber Eats is a three-sided marketplace, which is a little different than the Rides marketplace, which is just rider and driver. So you have the eater who orders the food, the restaurant who makes the food, and the delivery partner, the courier who picks up and delivers the food. So these three sides have to kind of stay coordinated. You have to have a ton of really interesting real-time product features and experiences that make this all possible. It's a non-trivial thing. A lot of times you kind of don't think about all the moving parts behind when you just click the button and track your courier and get the food delivered. But it's quite a complex marketplace that we have to execute. There's an app that that runs on tablets that the restaurants use. I'll talk a lot about this. It's actually built in React Native, interesting technology that we've been pretty big fans of. Some examples of what the app looks like. You can kind of see the orders come in. We also have an app for restaurants to track their analytics. How are they doing? What items are selling well? What items are not selling well? How could it be better? Give you a lot of analytics for a restaurant. In the driver side, couriers can see specialized instructions to kind of navigate and find parking. Yeah, a lot of interesting navigation and things like that as well. Let me walk you through a little bit of what the app itself looks like. You can see new orders coming in. You can see they kind of stack up. These are the people that are ordering food and when they expect food by. You can see the details of the food the restaurants can then prepare. They can confirm, they can mark it ready to pick up, and then kind of go through how you can manage the order. I want to kind of give you a flavor of what the app looks like, because you can kind of see it's a pretty full-featured application that we built it entirely in React Native. React Native, for those that are not familiar, really sophisticated, I should say, cross-platform framework that was developed at Facebook, and we've been pretty big fans of it because we use React here for web applications. Diving a little deeper, about 6 engineers that work on it. We support iPads, Android tablets, and web. About 100. We're largest food delivery platform in the world. However, the market is still very new. Some restaurants still use fax machines to get orders. So we think technology has a huge role to play. And then we think there's a lot of growth ahead for Uber Eats. We think a lot of people still haven't ordered food. We think as the price of delivery comes down, as the accessibility of delivery comes down, people will hopefully, just like how they in some cases stop owning cars, maybe they'll stop having kitchens. Cooking is still like an art form and cathartic social thing for many, but for the meals on the go, I think delivery is a great option. Kind of dig in a little bit about how we built it. We actually wrote a really good long blog post about how the app is built. It's built in React Native, as I mentioned. Initially, it was a web app, which we slowly migrated to a React Native app. Some of the reasons we went native was because it's pretty tricky to play music in the browser when the app is not foregrounded. So we realized we really needed a native application, which was an interesting revelation, but we were able to make that migration fairly straightforward. Talks a little bit in this slide here, talks a little bit about how, for us, in this case, we decided to do a lot of things in JavaScript rather than native iOS or Android. It allowed us to move a little faster over the last couple of years. We also do this thing that's called code push. Code push is an interesting sort of approach to delivering application code dynamically, which means like you can kind of go online and you can check before the app starts up as to what the latest version of the code is, rather than just use what's bundled in. And we kind of have to make sure that it's safe, because otherwise you may end up in a place where the app may crash if the latest version is not good. So here's an example of the original JS bundle, the JavaScript bundle. It has a stable version, and then it checks against this web service for the latest bundle. Kind of talks a little bit about how this works. And again, I'm not showing this to have you all fully understand all the specifics of how this works, but hopefully this gives you a flavor of, hey, we have this restaurant tablet that's running in these hundreds of thousands of restaurants. And then when it starts up, it checks to see, am I running the latest code? If not, pull down the latest code. Is that latest code safe? Is it working right? Is it crashing? If not, use that as the latest version and delete the previous version and move on. So pretty fun to build these kind of flows. Pretty challenging. You start to realize that this is the tablet that needs to be up and running for days on end, not just hours or minutes. This is the tablet through which restaurants get order. This is the tablet through which they make money. So we need to make sure it's up and running and very stable. So really pushes us as an engineering organization to make sure uptime is paramount, and we think through all of that. For JavaScript, we use Flow. I don't know how many of you have done JavaScript extensively, but it's a dynamically typed language, which means it's hard to tell what kind of variable or object you're dealing with sometimes. So we use this technology called Flow, which allows us to check the code statically and keep the code cleaner. We also use this concept called Redux sagas, which has been really helpful for us to do long-running things. So if you imagine, like I mentioned, the restaurant, the tablet is just on and running for days. Keeping an app running without crashing or having errors for days is actually quite an interesting challenge. Very different than the Rider app, where you may open the app, look for a car, hit confirm, and then you background, and then you just wait for the car to show up and get in. That's like, maybe half a minute, couple of minutes. That's a very different challenge where you just have to make sure the transaction is working, versus a tablet that's just up and running and telling the eaters that the restaurant's online, accepting orders. You saw all the different screenshots that the tablet has to support. So we use sagas to kind of manage that state and long-running tasks. For restaurants, we ship the tablet in a nice box. We have to test all these different tablets, Android tablet, iPad tablets. So that's sort of like our little mobile test lab. We also end up supporting printers. So you have 5 or 6 different types of printers that we have to support. Some of them are wired, some of them are Bluetooth. So we have to really test a lot of the interesting challenges around like sending the printing sort of format in different ways. You can see the different types of printers support different sort of formatting. So one of the older type of printer kind of just does black and white text, and that's it. It doesn't even give you like a line, so you have to kind of do dashes and kind of render that. Versus some of the newer printers kind of have like, you can have some nice different types of fonts and bolded text and background sort of black bars to kind of draw contrast and show interesting things. So it kind of just shows you how you can have, within the software, kind of dealing with printing, with connecting and staying online for days on end, to checking the latest version of code. That's kind of what I wanted to show there. Hopefully that gives you a little bit of a flavor of how Uber Eats works. This is specifically, I went in deep on Uber New York, Uber Eats, restaurant team, and then the sort of the restaurant in-store operations team, which is like the tablet and the printer and stuff like that. So that's sort of like all that I wanted to kind of quickly cover. At least wanted to save about 10 minutes for questions. Hopefully this gave you a little bit of a flavor of what we work on in the office. I have a bunch more things I can show, but I figured I'll pause there and take questions, and then we can go deeper or zoom out as people may have questions or other concerns.
Awesome. Thank you so much, Arun. That was great. All right, jumping into questions. First question was, what made you guys decide on React Native instead of OF Native?
Instead of, I'm sorry, what?
OF Native, I believe.
Okay. So yeah, I mean, specifically talk a little bit about React Native. So the initial version of the application was built by a team that was a bunch of web engineers. And yeah, it's like sometimes a religious debate between like React Native and using like native native SDKs. For us, it was a small team that just did the right thing for themselves in the business. We enable independent teams to kind of make their own decisions within reason, as long as it supports the larger business. And yeah, for us, like React Native has made sense for this specific for this specific application. But the Eater app or the Rider app or the Driver app, those are all like OS native. Like we build specifically for iOS and Android. It's an Objective-C, Swift, or Java. So different teams have made different decisions. And for this tablet team, it made sense to go React Native because the lineage of the code base was from a web application.
Okay, very cool. Thank you. All right, next question. Could you go into what the differences are between a software engineer and an engineering manager? Is it a natural progression or more a different career?
Yeah, really good question. Yeah, so I used to be a software engineer, and now I'm an engineering manager, so I can talk a little bit about this. So first of all, I'll say that at Uber and at most tech companies, there's no difference in terms of like any pay or prestige between managers and individual contributors. So you can be an individual contributor and grow and have a ton of impact and get paid a lot and really have a lot of fun. Or you decide at some point in your career that you derive a lot more satisfaction by seeing teams work together. You like seeing people develop. You have more fun, sort of challenging, sort of like organizational, solving organizational challenges. So that's sort of like the decision point. I still recommend everyone that wants to be a manager potentially to definitely, be an engineer for 5, 6, maybe 10 years. Just gives you like a really in-depth experience of what it's like to build software at different places and different times. So yeah, so at Uber at least, in order for you to become a manager, you have to have been software engineer before. I assume that's true in many other places. The difference is basically as a manager, you're not writing a lot of code. You still are very technical, but you're kind of dealing with sort of inter-team collaboration, making sure that your team is growing, executing, and that kind of stuff. And as an engineer, you're writing code, 80% of the time, perhaps, maybe a little more, a little less, depending on the week. You are responsible for just sort of your projects rather than other people's work. So that's the difference. And yeah, there's a lot more to go into there, but hopefully that gives you a little bit of difference, and then sort of also the progression for someone that may want to go into management. It's not for everyone. It's also like quite rewarding if you're into that, but it's definitely a very different career path.
Great, thank you. Next question, can you speak to some of the unique challenges with something like Uber Eats?
Yeah, so I'll tell you one of the challenges that kind of surprised me. So for instance, when you're in an Uber ride, the rider and driver can talk to each other, right? They can say, "Hey, I'm over by this curb. Pull over. I'll get off." Um, or the driver can like wave at the rider and say, "Hey, get in my car." Sandwiches cannot speak to you, right? So it's the amount of detail you need to provide in order for someone to get their food is very high. It needs to be like almost step by step, highly detailed. So if your address is not perfect, if the instructions are not perfect, it leads to like really, a lot of lost time, and the food's getting cold. People are hangry. So that's a very unique challenge I did not think about, which is, hey, we're moving people around. Why not move other things around? It's like, well, the people are, much more dynamic and can speak and can change their mind. But an order, it needs to kind of move almost in a robotic manner, still involving real world people. But that is a very interesting challenge one of many challenges, I should say.
Yeah, great. Next question. I've noticed that Uber's mobile site is a progressive web app, which is awesome. What are your thoughts on the progressive web app concept, and is Uber planning to embrace it going forward?
Yeah, so m.uber.com, it's a pretty awesome progressive web app. It actually allows you to request a car from a web app. It works really well. It does a lot of really cool things. I think for the restaurant app, since we are still using a lot of hardware capabilities like sound, push notifications, and some of the hardware is a little older Android tablets or older iPads. It's not clear how well PWAs work on those. So we plan to embrace it, but it's probably going to be a little while longer for us to get rid of what we have and build something new, such that the hardware platform support it. So I guess the simple answer is, at this point, we're just watching it. We have a piece of technology that's working, but at some point, given the ease of distribution, we may invest in that.
All right, next question. How prevalent is pair programming / code reviews in your team, on your teams?
Good question. Yeah. So every line of code is code reviewed. So 100% code reviews. Code reviews are great. It's a great way for people to learn. Both sides, I think, will learn. The person writing the code and person reviewing the code, they get to learn. It's a good way to obviously catch silly mistakes. It's a great way to enforce. It's a great way to enforce some standards and basics of what you want to make sure it gets done. And then also just it's a good way to people to get very humble about their work. You're not criticizing me, you're criticizing this piece of code, right? So it just sets that culture up so the feedback flows very smoothly. So code reviews are a must and very important, and we do that religiously. Pair programming varies by the person, by the team. So some teams do, when you first start, a few hours of pair programming. It's sort of like pair programming to me is a sort of a personal decision. So it's up to, I tell everybody like, hey, maybe you should pair program on this, and then they decide if they want to do it or not. They would sometimes prefer to just work separately and then have a meeting later on. Yeah, I think it's that's like a taste thing, because some people like their personal space, or they like to work by themselves and not be interrupted. So that one is up to each teams and up to individuals.
Very good. All right, running out of time, so I'm just going to pick a few more here. What mentorship opportunities are available for junior developers who join?
Yeah, so we have a pretty good sort of onboarding process. So I'll talk a little bit about how we work with junior engineers. So usually there's like a first week is a structured week where there's some classroom style onboarding, talk a little bit about the technology stack, some of the tools and technologies we use. And then we'll have something very small that you will code up and land and hopefully even deploy either the first week or the early second week. And then you'll be paired up with sort of an onboarding buddy. So this person will be sort of your first point of contact for any questions, anything from like, hey, where's the closest bathroom, to how do I solve this complex technology problem, right? Just to kind of have that, one-on-one support. Obviously, there's others around you as well, but at least there's one person that they're expecting any question from you and every question from you, and that's it, right? So we do that. And then there's also, as you kind of get onboarded on a project, there's a ton of other senior engineers that you get paired up with for more career mentorship or project level mentorship. And you meet with them maybe once every 2 weeks, a couple of times a month, depending on your cadence. And yeah, it's something we take pretty seriously, something we actually expect senior engineers to do. So as part of us being a solid and great senior engineer, you need to help others and mentor others. So there's an expectation of senior engineers. It's something we set up for junior engineers, something we take a lot of pride in, both in terms of like unstructured and structured mentorship.
Awesome. And then last question here. What does Uber's backend stack look like?
So different teams have different sort of stacks. Primarily across the company, we're big on Go, big on microservices. We use Cassandra a lot in our team. I think it's a common sort of backend, common database. Cassandra, pretty powerful NoSQL database. So those are two common things. And then as far as between microservices, we use Thrift as a standard for message passing. We're potentially looking at other alternatives in the future. We use metrics and monitoring heavily, so we want to make sure that every request is properly traced, every request is properly measured. Alerting then happens if something goes wrong. We use our own data centers primarily, which is cool. We're looking at the cloud, but we have our own data centers that is quite successful. We containerize our applications pretty heavily, which is good. Allows us to test in different environments quickly, running locally and all that stuff. And then we use ELK for sort of logging, debugging, visibility into our metrics and stuff like that.
Great. And just like that, we're at 12:30. Thank you so much, Arun, for taking the time out of your day to come and talk to everyone. I will be following up with you after this. Everyone else, thank you so much for joining. It's been a great presentation, and I hope you guys all have a good day. and we'll see you soon for the next one.
Thank you very much. Have a great day.